Please, Jen-Hsun.
Good morning, everybody. It's great to see all of you. You know, this if you think about and take a few steps back and think about what GTC is, it's one of those few conferences where it's not about the speeds and feeds primarily. I mean, it's always good to have some speeds and feeds and to get a sense of where technology is going. But this GTC is really about how people are using the technology to advance their work or to discover something wonderful. And so this is really about all of the scientists and researchers and the engineers out there who are doing amazing work. And so I think this is one of those rare conferences for them. This year, I wanted to highlight the advances of GPU computing more than anything. That because of the adoption of it, because it is serving a really important need, both because science needs to be advanced and more people are adopting computational techniques, what we call and what many have called the third pillar of science, from theoretical to experimental now to computational. More fields than you could really imagine are using computational techniques. So there's a great demand for GPU computing out in the world. And it simultaneously showed up at a time when we're finding that performance is having a very difficult time scaling because of power challenges and architectural challenges of processors that were really designed for instructional level parallelism in the past. And so those I wanted to highlight the advances of GPU computing, the needs of GPU computing, and the progress that we've made. And so during the course of the next several days, you're going to see some really amazing stuff. The papers out in the hall there is a really good early indicator of the type of things that we've been listening about.
Great. Any questions, please? Yes, over there.
Yeah.
If you could just identify yourself, please.
I'd like to understand more about how you're getting CUDA into mainstream compilers and development environments. So the Fortrans that the scientific computing folk are using, and also into tools like general purpose tools like Eclipse and Visual Studio.
Sure. So my name's Sam Wilson. So we've had a relationship with a company called PGI, which makes a Fortran compiler. So the developers do Fortran, as well as a Fortran accelerator, and that's been around for about a year and a half now. Today we announced with PGI we're going to be showing it actually at Supercomputing with PGI, the x86 compiler for CUDA-C, and with the objective of making this a pervasive programming model. We've had a lot of customers, Andy's customers specifically, where they build out one data center, but they might have a data center that's 2-3 years old. They don't want to roll that right away. They want to make sure the code can run there. And so this is a great solution for those markets. As the market rolls out the GPU acceleration into the data centers, we can bring the entire data center plant in at once. So this is a very important and strategic move for us.
And the same again. So in our philosophy of providing these tools are very much driven by the developer. So you can see that same effect at GTC, where we have a lot of the scientists and researchers who are actually producing the code. They actually tell us what they want in terms of the types of compilers, the types of tools, and those are the ones that we specifically target. So it's really responding to whatever the developer needs to make them make their code get faster and more productive. Those are the ones we target.
Good. Thanks. Dean, did you have a question?
Yes. For Jen-Hsun, I guess there were a lot of years where you were introducing a new architecture once a year. It looks like with this new cadence that you've gone to once every 2 years. Is that sort of the basic plan now?
The basic cadence has to follow processor advancement. You know, unless there's a major new node in the process, it's hard for us to come out with enough transistors to fundamentally change the architecture in some meaningful way. Going forward, I think what you're going to find is that we're going to have a new process node about every 2 years. Okay, now, if it's every 18 months, then we'll change our architecture roadmap so that we would align to every 18 months. But if it's every 2 years, then we'll run on that rhythm. In between, we will likely have a midlife kicker, if you will, something that enhances the microarchitecture features within that. And so you're going to see this coming in the near future for next year, the midlife kicker for Fermi, and then you're going to see Kepler, and then you're going to see the midlife kicker for Kepler, and then you'll see Maxwell, and so on and so forth. Okay, so that's basically what